Article 314.28 of the National Electrical Code specifies box sizing requirements for conductors larger than number 4 American wire gauge. This requirement is based on the cross-sectional area of the conductor, not its overall diameter. Belden cable is typically composed of smaller gauge conductors stranded together within an overall jacket. Therefore, the cross-sectional area of the cable is significantly smaller than the cross-sectional area of a number 4 American wire gauge solid conductor. While it is important to comply with NEC requirements, it is also reasonable to apply common sense in certain situations. In the case of low-voltage Belden cable runs, using an excessively large junction box may not be necessary. If the Belden cable is flexible enough to be easily installed in a smaller box, it is likely that the box size is adequate for the application. To determine the appropriate box size for low-voltage Belden cable runs, consider the following factors. Firstly, consider the number of cables. Determine the total number of Belden cables that will be housed in the box. Secondly, calculate the cross-sectional area of cables. Calculate the combined cross-sectional area of the Belden cables using the cable manufacturer's specifications. Thirdly, consider the box cubic capacity. Use the cross-sectional area of the cables and the NEC box fill requirements in Table 314.16b to determine the minimum cubic capacity of the box required. Fourthly, consider the box shape and layout. Choose a box shape and layout that allows for the cables to be installed and terminated easily. While Article 314.28 of the NEC provides guidelines for box sizing for conductors larger than number 4 American wire gauge, it is important to apply common sense and consider the specific application when determining box size for low-voltage Belden cable runs. Based on the information provided, a 4-inch square box is likely to be sufficient for most low-voltage Belden cable runs, as long as the cubic capacity and cable fill requirements are met. When working with electrical systems, safety is paramount. Always de-energize circuits before working on them. Wear appropriate personal protective equipment, including safety glasses and gloves. If you're unsure about any aspect of the electrical work, consult a qualified electrician. The National Electrical Code, or NEC, is a comprehensive set of standards that govern electrical installations in the United States. Adherence to the NEC is crucial for ensuring the safety and reliability of electrical systems. The NEC is updated every 3 years, so it's important to stay current with the latest edition. Article 314 of the NEC covers outlet, device, pole, and junction boxes, conduit bodies, fittings, and handhole enclosures. This article provides detailed requirements for the selection, installation, and use of these components. When selecting a box, it's important to consider the number and size of conductors that will be installed in the box. The NEC provides tables that specify the minimum box size required for various conductor combinations. It's also important to consider the volume of the box, which is the amount of space available inside the box. The volume of the box must be sufficient to accommodate all of the conductors, devices, and fittings that will be installed in the box. When installing a box, it's important to ensure that it is properly supported. The NEC specifies the types of supports that are required for various types of boxes. It's also important to ensure that the box is properly grounded. The NEC specifies the methods for grounding boxes. When using conduit bodies, it's important to select the appropriate type of conduit body for the application. The NEC specifies the types of conduit bodies that are permitted for various applications. It's also important to ensure that the conduit body is properly supported. The NEC specifies the types of supports that are required for various types of conduit bodies. When making splices in boxes or conduit bodies, it's important to use approved splicing methods. The NEC specifies the types of splicing methods that are permitted. It's also important to ensure that the splices are properly insulated. The NEC specifies the types of insulation that are required for splices. In addition to the NEC requirements, it's also important to follow the manufacturer's instructions for the installation and use of boxes, conduit bodies, and fittings. The manufacturer's instructions may provide additional information that is not covered in the NEC. When working with low-voltage systems, it's important to understand the specific requirements for these systems. The NEC contains specific requirements for low-voltage systems, including requirements for wiring methods, overcurrent protection, and grounding. Belden cable is a type of cable that is commonly used in low-voltage systems. Belden cable is typically made of stranded conductors that are insulated with a PVC jacket. Belden cable is available in a variety of sizes and configurations. When selecting Belden cable, it's important to consider the voltage and current requirements of the system. It's also important to consider the environmental conditions in which the cable will be installed. In some cases, it may be necessary to use a shielded Belden cable to protect the signal from interference. Shielded Belden cable has a metallic shield that surrounds the conductors. The shield is connected to ground to provide a path for unwanted signals to dissipate. When installing Belden cable, it's important to follow the manufacturer's instructions. The manufacturer's instructions may provide specific information about the cable's bending radius, pulling tension, and termination methods. It's also important to avoid damaging the cable during installation. Damaged cable can cause shorts, opens, and other problems. When terminating Belden cable, it's important to use the correct tools and connectors. The use of incorrect tools and connectors can damage the cable and cause poor connections. It's also important to ensure that the terminations are properly insulated. Improperly insulated terminations can cause shorts and other problems. When working with electrical systems, it's always important to prioritize safety. Never work on energized circuits. Always de-energize circuits before working on them. Wear appropriate personal protective equipment, including safety glasses and gloves. If you're unsure about any aspect of the electrical work, consult a qualified electrician. In the specific scenario of sizing boxes for low-voltage Belden cable, remember that the NEC Article 314.28 primarily addresses conductors larger than number 4 American wire gauge. The key here is the conductor size itself, not the overall diameter of a cable assembly. Belden cables often comprise multiple smaller gauge conductors bundled together, usually fall well below this number 4 American wire gauge threshold. Thus, the stringent box sizing calculations outlined in 314.28a, which often dictate box dimensions 8 times the raceway size for straight pulls, may not be strictly applicable. That's where the element of common sense, as mentioned earlier, becomes relevant. While strict adherence to code is paramount, especially in scenarios involving higher voltages or currents, the practical realities of low-voltage installations often permit a more flexible approach. A smaller box, such as a 4-inch square box, may be entirely adequate if the Belden cable's flexibility allows for easy installation without undue stress or crowding. To definitively determine the appropriate box size, you need to consider several factors. First is the number of Belden cables entering the box. More cables naturally demand more space. Second, determine the cross-sectional area of each cable and sum them. Cable manufacturers typically provide this information in their specifications. Third, consult NEC Table 314.16b, which dictates the minimum cubic inch capacity required for boxes based on the number and size of conductors and devices within the box. This table will provide a definitive answer based on your specific cable configuration. Fourth, consider the physical layout of the box and how the cables will enter and exit. A box with strategically placed knockouts can ease installation and minimize bending stress on the cables. In summary, while the large box size is dictated by 314.28 may seem excessive for low-voltage Belden cable runs, always prioritize safety and code compliance. Apply engineering judgment, carefully assess the cable characteristics and box fill requirements, and consult the NEC tables to determine the most appropriate and safe box size for your specific application. Remember, when applying the code, use common sense when the strict guidelines may not be applicable, without compromising the intent of the code, which is safety. The goal is to provide a safe, reliable, and maintainable electrical installation.